All right, here is the rest of the notes that we were not able to cover. All right, so we're going to consider this statement. Okay, so if two triangles are congruent, then they are similar. Okay, so we're going to determine if this is true or false. So remember, based on the other triangles that we were talking about, just because a triangle was similar did not mean that it was congruent. But if a triangle is congruent, if a triangle is congruent, like example 2, they were in fact similar, okay? So is the statement true? Yes. Okay, now we have to explain, okay? So if a triangle is congruent, okay? So if a triangle is congruent, they have equal sides. Okay, and so if they have, sorry, I want to make sure my microphone is on. Okay, if they have equal sides, okay, then the ratio, I misspelled that, sorry. The ratio of corresponding sides are equal. Because remember, okay, we only, we know if things are similar if the ratio of their corresponding sides are equal. Kenley, go shut that door for me. Go shut that door. Sorry, guys. Okay, so we're going to fill in the blank to write the converse of if two triangles are congruent, then they are similar. Now remember, converse means that we just flip the sentence around. Okay, so if two triangles are congruent, then the triangles are similar. The converse of that would be if two triangles are similar, then the triangles are congruent. Okay, we just kind of flip that around. Okay, but then we need to say, is that a true or a false statement? So just because two triangles are similar, does that mean that they are exactly the same? Okay, so take a moment to think about that. Okay. And I'm actually going to refer back to example 1. So on example 1, the triangles were similar because the side lengths were the same, or the ratios of the corresponding sides were the same, but they weren't congruent because the side lengths weren't exactly the same. Okay, so is it true or false? It would be false. Okay, and so similar triangles are not always congruent. Okay. All right, pause it if you need to. I'm going to go ahead and go on so that way this video isn't too long and takes forever to upload. Okay, so now we're going to verify right angles using the slope. And so right angles, as we know, okay, they are formed by perpendicular lines. Okay, and what that means is like if I have lines that cross, okay, and form 90-degree angles. Now remember that, and this is back from maybe unit 3, I think. Okay, recall that perpendicular lines, okay, they have the opposite reciprocal slope. Now, before I go on, I want to remind you, opposite reciprocal means like if one has a slope of 3/4, okay, opposite reciprocal would be -4/3. So remember, we change the sign to the opposite sign, and then we flip the fraction. So we're going to use rise over run, or you can use the slope formula to determine the slope of a side or the slope of a line. Now, one thing to remember, and this is really important, horizontal lines, so side to side, okay, they have a slope of 0. And vertical lines have an undefined slope. Okay, so that's important to remember. All right, so on example 4, it says it's triangle XYZ, a right triangle. So what we're looking for here, okay, is do we have opposite reciprocal slopes? Okay. All right, so I'm going to find the slope of ZY, And in that order, I'm going from Z to Y, okay? And I'm just going to use rise over run. So I rise 1, 2, so my top number is 2. And then I'm going to run 1, 2, 3, 4, 5, 6. Now, one thing that you have to remember is that you have to simplify the fraction. So 2 over 3 is going to simplify to 1, 2 over 6 is going to simplify to 1 over 3. Okay? So now, I can tell right now that, well, actually, never mind. Okay, now I'm going to check ZX. So I'm going to go from Z to X. Okay, and I'm going to see, well, what is that slope? Okay, now I'm going down, so it's going to be negative, and I only went down 1. And then I'm going to run. I run 1, 2, 3, 4, 5, 6, 7. So the slope of ZX is negative 1 over 7. Now, those two slopes, okay, my 1/3 and my negative 1/7, they're not opposite reciprocals. However, I still have a third side, YX, that I have not found yet, okay? So I need to find Y over X. Or, YX. I need to find the slope of YX. Now, I'm going down 1, 2, 3. So I go down negative 3, and I run 1. So now I'm going to look at, okay, so negative 1 over 7 and negative 3 over 1. Those aren't opposite reciprocals. However, ZY, which is 1/3, and YX, which is negative 3 over 1, those are opposite reciprocals. Okay, so yes, these lines, this is a right triangle. Okay?
We need scissors.
Okay. All right, let's go over here to B. So on B, I'm going to find the slope, of each side. So I'm going to find the slope of YZ, and I will tell you guys, it doesn't matter which side you find in what order, okay? It does not matter at all. I'm just picking YZ. I don't know why. Now, from Y to Z, I'm going down. So I go down 1, 2, 3, 4, 5, 6. So because I go down 6, it'll be negative 6, and I run 1. So my slope of YZ is negative 6 over 1. Now remember, you're more than likely always going to just see negative 6, okay? That 1's not going to be there. Okay, so now I'm going to find the slope of, let's see, ZX. Let's do that one next. So when I go from Z to X, one thing to remember that I haven't said, probably should have said already, but when we look at the slope, we always start with the farthest left point. So that's why I'm starting with Z, okay? So whenever I go from Z to X, I'm going to rise 1. And then I'm going to run 1, 2, 3, 4, 5. Okay. Now, looking at my two slopes here, I have negative 6 over 1, and I have positive 1 over 5. They do have opposite signs, but they're not the just fraction flipped. Okay. So those are not going to be opposite reciprocals. Excuse me. So now I need to find YX. Okay. So when I go from Y, because Y is my far left side, to X, okay, let me erase these kind of stray marks here that I've got going. Okay, so that way I can help you. All right. So when I go from Y to X, I go down 1, 2, 3, 4, 5. So negative 5. And I run 1, 2, 3, 4, 5, 6. Okay. And so whenever I look at the slope of each side or each of the 3 lines, okay, I have negative 1 over 6, positive 1 over 5, and negative 5 over 6. And none of these are opposite reciprocals. Okay, so because you do not have opposite reciprocals, no, okay, this is not a right triangle. Now, I apologize, I did not see this part. When you justify, we need to use the word slope in our response. So no, how would I use the word slope to say, no, this is not a right angle? Okay. So one thing that pops into my head, and of course you can say it in a different way so long as it's saying the same message here. No, okay. the sides slopes are not opposite reciprocals. Okay? So that's how we would justify that that is not a right triangle. Okay? Because I will tell you, somebody may say, but this looks like a right triangle. Okay? And I would say, yeah, it looks like it. But we can't assume that it's a right triangle. We need to do the math, which wasn't too hard of math, guys. But we need to do the math to prove if it is or if it isn't. Okay? All right. Again, if you need to pause the video, go ahead and pause the video as I go ahead and go on to the next page. Okay, so we're going to use this figure below to answer this question A, B, C, and D, okay? And there are multiple questions for some of the questions. So we're going to look here. Describe the transformation used to go from A, B, C. So our green triangle to our blue triangle, okay? We're going to look and see. So as a reminder, and I'm going to write them up here. You can choose if you want to write them. But as a reminder, we have translation, and I'm just giving you the options of the transformation, excuse me. Translation, we have rotation, reflection, and dilation. Okay, those are the four transformations we have to choose from. So when I look at this, so the translation, okay, what's kind of helpful is the SL. So that means slide, right? Rotation has a T, and that means turn. And then reflection has the FL, which I think of flip. And then dilation, there's really not a way to look in the word itself. But dilation, like we have talked about, means getting bigger or smaller, okay? Excuse me. Now, whenever I look at the word translation, did it slide? Okay? Did it slide up, down, left, or right? Okay? And it did not. It's still going to keep the same orientation, but it didn't slide. So then we look at the word rotation. Well, if I rotated it, okay, I'm going to look at the word rotation. So if I rotated ABC around, it would look something like this, okay? But that didn't happen, so it's not going to be a rotation. Now, did it flip? Was it a reflection? We have a mirror here, and it flipped. It was a reflection, right? Think of a mirror, okay? And it did reflect, so it is a reflection. Now, where did it reflect on? And so I drew this yellow line because that's where it's reflecting at. And that yellow line is also the x-axis. So it's a reflection over the x-axis. Okay? So this is saying explain the relationship between congruent triangles and similar triangles. Okay? So here's our relationship that we're going to talk about. So all congruent triangles, oh goodness, I'm not writing this very clear, sorry. Congruent triangles are similar. But not all similar triangles are congruent. Okay, and so because remember, just because they're similar, they have the same ratio between their two sides or their corresponding sides. That doesn't mean that they're the exact same size or exact same size, exact same shape, right? All right, so on B, we're going to use side angle side congruence theorem to prove that triangle ABC is congruent to triangle DEF. And so we're going to use three congruence statements to justify write three congruent statements, okay, to justify each statement. Now, this is important. Side, angle, side. So I know I'm going to have a pair of sides that are congruent, an angle that is congruent, or another side that is congruent, okay? So, and again, you can choose which one you use here. Okay, we're going to kind of join the things that we are like, combine the things that we've been learning about. Okay, so let's see. Let's do our angle last. Actually, no. Nope, let's not do our angle last. We're going to see if they are opposite reciprocals. Okay, so I'm going to find the length of BC, or the slope of BC. I'm sorry, I said the wrong word. So when I go from B to C, I go down 1, 2, 3, 4. So that's -4. And I run 1, 2, 3. Okay. AC. Okay. Going from A to C, or C to A, excuse me. Because C is on the left. I'm going to go up 1, 2, 3, 4, 5, 6. Oh, sorry, guys. 6. And I'm going to run 1, 2, 3, 4, 5, 6, 7, 8. Now, you look at this and you say, well, those aren't opposite reciprocals. But remember, our slope is supposed to be in a simplest form. So I'm going to put 6 over 8 in the calculator. Okay, I'm going to go ahead and do it here. So I'm going to do alpha y equals enter. So 6 over 8. And it says, mine will say 0.75. Yours will go ahead and give it to you in fraction form. So 3 over 4. So I know that 6 over 8 reduces to 3 over 4. Is this 3/4 the opposite reciprocal of -4 over 3? It is. So that means that this is a right angle. Okay. All right. So now I need to see, is the corresponding angle, okay, is the corresponding angle a right angle? So what angle is corresponding with C? And that is F. Okay. So I'm going to see. Okay, so FE, I'm going to see what the slope is. So I go up 1, 2, 3, 4. And I run 1, 2, 3. And then I'm going to find what the slope of FD is. Because remember, I'm looking for angle F. Oh, I don't know why I did the congruent symbol. I'm looking at angle F. So I need to make sure that those sides, next to it, that they are, in fact, perpendicular. Okay, so FD. So now, going from F to D, I'm going down. So I go down 1, 2, 3, 4. Oh, 5, 6, excuse me. So it's -6. And I run 2, 3, 4, 5, 6, 7, 8. I run 8. So I need to see, does -6 over 8 reduce to 4 over 3? Okay. So if I did alpha y equals, oh, hold on, let me delete this. I didn't realize I had this in there, sorry. Alpha y equals enter. And I did -6 over 8. Math, enter, and I get -3 over 4. Okay. So this is -3 over 4. So 4/3 and -3 over 4, those are opposite reciprocals, which means the F up here is also a right angle. Okay. So I know that angle C and angle F are congruent. And the reason I know that is because I checked to see if those sides, FD and FE, and BC and AC, if they were opposite reciprocals. And because they both have a right angle here, okay, right angles are congruent to one another, okay? All right, so now I need to find out, are the sides congruent, okay? So I'm going to see, okay, I'm just going to pick some corresponding sides. It doesn't matter which one. So I'm going to look and see, is FE and BC, are they congruent? Okay, because they look like the shortest sides to me. Okay, so remember, this is when I'm going to use my distance formula. So I'm going to need to find the points where the location is of BC, or of B and of C. So B is at -5 over -1. C is at -2, -5. Okay? And so because of that, I'm going to go ahead and label x1, y1, x2, y2. So my distance formula says this, square root of x2 minus x1 squared plus y2 minus y1 squared. And I forgot my 1 right there, okay? All right, so now I'm going to plug this information in. So I would have -2 minus -5 squared plus -5 minus -1 squared. And don't forget to do the square root. I almost forgot that. All right, so I'm going to plug this information in. I wish I could split screen this, but I don't know how. Let me see if I can do it this way. There we go. Now I'll have to thumb back and forth for my calculator. Okay. Oh, maybe I can't do that, guys. I'm sorry. Okay, so I have, let me remember, square root of -2 minus -5. So second, x squared. -2 minus -5 squared plus, I'm going to have to go back here. What does that say? -5 minus -1. Okay. -5 minus, was it minus -1? Yeah. Okay, -1. Oh, I forgot my parentheses. Squared. And I get 5, okay? So that means the length of BC is 5. So BC equals 5. No, you can be quiet. So now I'm going to check EF. So I need E and I need F, the location. Okay. So E is at -5, 1. F is at -2, 5. So now I'm going to use my distance formula, which I'm not going to rewrite it. But I'm going to label my points. So E, I'm going to have x1, y1. And F, I have x2, y2. So I have the square root of, it says x2 minus y2, so -2, I'm sorry, x2 minus x1, sorry. -2 minus -5 squared plus 5 minus 1 squared. And so I'm going to go into my calculator. Second, x squared. I already forgot my numbers. -2 minus -5 squared plus 5 minus 1 squared. And I get 5. So did we get the same length on these two sides? So that means, what did I say? EF. So because we got the same length on those sides, that means that line segment BC is congruent to line segment EF. Okay. All right, and I need one more side, or one more pair of sides. So now I'm going to look at whichever side you want to do that looks like it's the same. So it looks to me like AC, so this side here, is congruent to FD, and I'm going to show if it is. Okay, so AD, isn't that what I said? I'm sorry, AC. So I need to know where A is and where C is. Okay, so look on your paper. I'm not going to zoom out again. But A is at 6, 1. And then C is at -2, -5. Okay, so again, I'm going to use my distance formula. Actually, I'm going to label first. So 6 is going to be x1, 1 is y1, -2 is x2, -5 is y2. Okay. So I'm going to do the square root of negative 2 minus 6 squared plus negative 5 minus 1 squared. All right, and so I'm going to use my calculator. All right, and I'm going to do negative 2, oh, sorry. Nope, wrong thing. Second square root, negative 2, what was it? Negative 2 minus 6 squared. Oh, I forgot my parentheses over here. Plus negative 5 minus 1 squared. And I get 10. Okay, so I know that AC equals 10. Oh, I forgot the C. Okay, and so I'm going to see is AC congruent with DF. So I need to know where D is. I need to know where F is. F is at, D. D is at 6, negative 1. Okay, F is at negative 2, 5. Okay. So I'm going to do the square root. Oh, I keep forgetting to label, and that's one of the things I always do when I do this. I'm sorry, y'all. So x1, y1, x2, y2. So I'm going to do the square root. Okay, so x2 minus x1 squared plus y2 minus, that's a 1. Sorry, I couldn't tell what that was. Minus y1 squared. Okay, so I'm going to go plug this in my calculator. Negative 2, I think it was, minus negative 5 squared. Oh, what am I doing here? I'm sorry, y'all. So negative 2 minus negative 5, good grief, squared. Oh, dadgummit. Hold on, let me start over. Negative 2 minus 6 squared. Sorry, I was getting two problems mixed up there. Plus 5 minus negative 1. And I got 10. So DF is also 10. So see how AC and DF both equal 10? That means that line segment AC is congruent to line segment DF. Okay? Now it says, explain how to show that triangle ABC is similar, to triangle DEF. Okay, using the side angle side triangle similarity theorem. Okay. Trying to think where I'm not. Okay, so this is what we're going to say. This isn't going to be an exact sentence, but you're going to understand, okay? Because we had two sides and the angle, actually, I'm not the word angle, angle in between those two sides that were congruent, then we proved that the triangles were similar. Now I'm going to put a little asterisk here. Remember that congruent triangles are similar. Okay. Now, I will not be available by email today, so if you have any questions, you can email me, but I will get it to you as soon as I am able, okay? if you have any questions, make sure that you're working with each other as well and trying to get some help from each other, maybe to understand, because I think it's really important for y'all to talk with one another, okay? All right, if you have any questions, feel free to let me know. I'll get back with you ASAP. Have a great weekend. Remember, no school on Monday. Have a good and safe weekend. Another thing, make sure that you have everything written down on your notes and that you completed your notes. I will be doing a note check on Tuesday. If you did not do the notes like you were supposed to, you will get a 0 for this. And that is a really silly thing to get a 0 for. Have a good weekend.